What is the main obstacle to writing correct software on time and on budget? Hi, my name is Eric Normand, and these are my thoughts on functional programming. So, there's a book called The Mythical Man-Month that talks about one of the main challenges of software is its complexity. That software is just complex, and it's just going to take time and energy to make it correct, to make it work for us. And I think that's fair to say. He talks about in the book, Fred Brooks, the author, talks about two kinds of complexity: essential complexity and accidental complexity. Essential complexity is complexity you cannot avoid, and accidental complexity is, complexity that you add that you didn't need to, that there might have been a way that you could have gotten along without it. And that's, that for what it's worth, that's kind of a fair way to divide it up. But there was a paper about 14 years ago, I think, called Out of the Tar Pit. And this is a very influential paper in the functional programming world because it does a little bit better at dividing up the complexity, of defining the two types of complexity than Fred Brooks did. For instance, Fred Brooks said, there's just a lot of state in software, and that's unavoidable. And as functional programmers, talking about state as unavoidable, we know that's not true. You can avoid it. So this paper defines essential complexity, I think, in a more useful way, where essential complexity is complexity that is due to the domain. So if you are going to be making a piece of software about rocket science is just complex by itself. So your software has to have at least that much complexity, as much complexity as rocket science. All of that is due to the domain, so it's essential. You wouldn't be doing rocket science correctly if you didn't have that complexity in it. However, there's another kind of complexity, which is all the complexity that we add as software developers. This is everything that has nothing to do with rocket science. So this is threads, the file system, exceptions, syntax errors, types, like all that stuff is complexity that is added on to the system. If it adds complexity, some things you could argue these are actually removing complexity, but in general, if there's some complexity and it's due to something that when you name it, it is not naming a rocket science thing, it's naming a computing thing, that is actually accidental complexity. And what this gives us is sort of a minimum floor for our complexity, and everything else above that is all accidental. We can work with it to reduce the complexity, or at least manage it better. Know that we're introducing complexity, but we're managing it. So I say we're introducing complexity. For instance, what the platform you're running on is going to have complexity. It's going to have accidental complexity by itself. So that means, you're making web-based rocket science software. Now you have to deal with browsers, the DOM, the AJAX requests, HTTP, like all this other stuff that has nothing to do with rocket science, that just has its own semantics, and some of those semantics have complexity to them. You have to deal with timeouts of your network requests. You have to deal with all the different response codes when maybe you only needed 2, right? Like these are the kinds of complexities that start adding up. And in general, I think we see in most software that the accidental complexity swamps out. It's way bigger than the essential complexity. So that means that in your rocket science software, most of the complexity is due to the implementation and not to rocket science itself, which is kind of a sad fact, but that's also optimistic. It means there's a lot of room for improvement. That we're doing this to ourselves as programmers. We're adding in, some things are maybe functional or operational requirements that are not part of rocket science. So you might have a functional requirement that says we have to implement all of rocket science. Okay, that's great. But then you might have a requirement that says, and it has to run in the web browser. Okay, so this has to be web-based software. Now, it's a requirement. You're going to have to take on all of this complexity, right? And it's something that the business has to decide that the deliverability, the availability of the web as a platform has its benefits versus the cost of all that complexity. Because complexity costs money, costs time, developer time dealing with, and the real reason it costs time is because when you have something that's complex, it's hard to hold in your head. We have limited space, if you will. It's a metaphor. We have limited capacity in our heads, in our minds, to understand complex things. And the more complex it is, the harder it is to hold in our head, and that's gonna cause bugs. We're gonna forget things as the system gets more complex. Things slip through the cracks, and so we need help. We need to do something about that complexity. And the tar paper book, out of the tar pit paper, is all about using functional programming to reduce complexity. And it does a good job of beginning that search, sort of laying the groundwork for how functional programming can reduce complexity. I feel like there is a lot left out that we still need to deal with. For instance, it kind of hand waves around state, about mutable state and storing things durably over time, and that's fine. It was a paper. It had its scope, and it's still a very great paper. So I suggest you all read it. But one thing that we can do, besides just sort of eliminating unnecessary stuff that we're adding, right? Like, do we really need mutable state here? Maybe not. Do we really need extra threads here? Maybe not. So those things, are kind of obvious. Eliminate them, sure. But then there's got to be some stuff for managing it, maybe for making it easier to work with. These are like developmental concerns. So, for instance, if you could encapsulate the complexity behind something that is a good abstraction, let's call it that. So, if you could somehow take all of the complexity of reading in files and storing them and stuff, and just turning it into a simple interface that you don't have to worry about it. So if this complex thing is written correctly, I can stop thinking about it. So that's one way of dealing with complexity, is to encapsulate it. Another way is to cut stuff into smaller pieces. So if you have two complex pieces, and I'm going to get into this more in a future episode, but if you have two complex pieces and you break it up if you have one big complex piece, you measured its complexity, and then you broke it up, the complexity, not only is it easier to fit in your head because it's smaller, it's two smaller things, but the complexity is actually cut in more than half for each piece. So the reason is that complexity compounds super linearly, depending on the type of complexity. But just as an example, the complexity of the number of code paths you have in, say, a routine, a function, that complexity multiplies. So every time you branch, so let's say, simple case, you just branch into two possible, you have a conditional, it has two branches, an if, it's an if statement with a then and an else. Every time you add one of those to your function, it will multiply the number of possible code paths by 2. So if you get rid of one, you're actually reducing the number of code paths by, you're dividing it by 2. So if you multiply them out, as when they're in a big single unit, like one function with 10 code paths, that's 2 to the 10th power possible code paths. You have 10 conditionals with 2 branches each. That's 2 to the 10 code paths. If you cut that in half, so you have 2 functions with 5 branches each. Let's say you could do that. Then 5 conditionals each, 2 branches on each conditional. Then that's 2 to the 5 plus 2 to the 5. Right? So that's way less. Before you had 2 to the 5 times 2 to the 5. That's 2 to the 10. But if you do 2 to the 5 plus 2 to the 5, you have significantly reduced the amount of complexity. And so with tricks like this, they're manipulations, skillful manipulations of the units that we have to reduce the complexity and just make it easier to work with. And the code should do the same thing, but have fewer, it's less to hold in your head. Let's say it that way. All right. My name is Eric Norman. This has been a thought about functional programming. You can reach me over email at eric@lispcast.com. I do enjoy getting people's emails and hearing about your thoughts on my thoughts. You can also reach me on Twitter. I'm at Eric Normand. Follow me and, message me, mention me, and we'll get into a cool discussion. I really appreciate doing that. So thank you so much for listening. Subscribe where you subscribe to this, and you'll hear about the next one when it comes out. Awesome. Thanks so much. Bye.